Hello everyone, myself Sasireka, Academic Coordinator, Department of Computer Science, Artificial Intelligence and Data Science. Today let us discuss about the process and product concepts in the software engineering. So, introduction. The product represents the tangible outcome of the development efforts and encompassing the software application, system or solution designed to meet specific user needs. The process provides the framework for organizing development efforts, managing resource efficiently, and ensuring the quality and reliability of the final product. Both the product and process form the cornerstone of the software engineering, guiding teams in delivering successful software solutions that meet stakeholders' expectations and contribute to the technological advancements. Software process. The term software process specifies to the set of computer programs, procedures, and associated documents that describe the program and how they are to be used. The software process is the set of activities and associated outcome that produce a software product. Software engineers mostly carry out these activities. These are four key processes which are common to all software processes. The activities are software specification, software development, software validation, and software evolution. In the case of software specification, the functionality of the software and constraints on its operations must be defined. Software development, the software to meet the requirements must be produced. Software validation, the software must be validated to ensure that it does what the customer wants. Software evolution, the software must evolve to meet the changes of client needs. So here we discuss about the software process model. In software process model, we have it is specified definition of software process which is presented from the particular perspective. Models by their nature are a simplification. So a software process is an abstraction of the actual process which is being described. Process model may contain activities which are part of software process, software product, and the roles of people involved software engineering. Some examples are waterfall model, data flow model, role action model, etc. So in the case of waterfall model, it can be classified into requirements, design, development, testing, deployment, and maintenance. In case of waterfall model, we have so many phases. In the case of sequential phase, the waterfall model divides the software development process into distinct sequential phases, including requirement gathering, design, implementation, testing, deployment, and maintenance. Each phase relies on the completion of previous one, promoting a structured and systematic approach to development. Clarity and structure. This model offers clarity and structure by defining specific activities by deliverable for each phase. Developers and stakeholders have clear understanding of what needs to be accomplished at each stage, reducing the ambiguity and enhancing communication throughout the project lifecycle. Documentation. In the case of the waterfall model, emphasize comprehensive document at each stage of development. This documentation serves as the valuable resource for understanding project requirement, design decisions, code implementation, test plans, and maintenance procedures. It facilitates knowledge transfer, collaboration, and future enhancement. Risk management. By following the sequential approach, the waterfall model allows for yearly identification of mitigation of risk. Since each phase must be completed before moving to the next phase, potential issues are identified and addressed in the earlier stage, reducing the likelihood of major setbacks during the large stages of development. Client engagement. The waterfall model often involves the existence of client involving during the requirements gathering and design phase. This engagement ensures the client expectation and clearly understood the incorporated into the final product. Additionally, clients have opportunities to provide feedback and make adjustments before the significant development work occurs, resulting in a product that better aligns with the needs. These are the important key aspects of the model. The next one is data flow model. Here we have important key aspects as concurrency, synchronization, flexibility, scalability, fault tolerance. In the case of concurrency, one of the fundamental aspects of the data flow model is its emphasis on concurrency. In this model, computations are represented as a network interconnected process model, nodes where each node performs a specific operation on incoming data independently. This allows for a parallel execution of tasks, enabling efficient utilization of computing resources and potentially reducing overall execution time. Synchronization. The data flow model provides the mechanism for synchronizing data-dependent computations. Nodes in data flow graph communicate by passing data tokens along edges, and synchronization points ensure the node execute only when all the requirements input data is available. This ensures the consistency and correctness in the processing of data across the system. Flexibility. The data flow models offers flexibility in their designing and implementation system, as their graphical representation makes it easier to visualize data dependencies and parallelism in the system, facilitating understanding and maintenance of the system. Scalability. The data model inherently supports scalability as it enables the execution of computations in parallel across multiple processing units. This makes it well suited for handling large volumes of data and accommodating varying workload demands, thereby improving overall performance and throughput of the system. Fault tolerance. The decentralized nature of data flow model enhances the fault tolerance in distributed systems. Since computations are distributed across multiple nodes, failure in individual components can be isolated and managed without affecting the overall system. Additionally, the data flow framework often incorporates mechanisms for fault tolerance, fault recovery, and resilience, further enhancing the reliability of the system. Role action model. Here we have traceability and accountability. Each action in the role or action model is associated with one or more roles responsible for its execution. This promotes the traceability as it becomes clear who performed a particular action and when it was executed. Additionally, assigning explicit roles and responsibilities fosters accountability, ensuring the individuals are held responsible for their actions within the system. Support for the compliances and governance. The role or action model can support compliance with the regularity requirements and governance framework by ensuring that appropriate controls are placed in that responsibilities are clearly defined and enforced. This particularly important for industries such as finance, healthcare, and government, where regularity compliances is critical. So this is the diagram for waterfall model, evolutionary development, formal transformation, system assembly, reusable components. Thank you.